This is a lesson about 9.4. In 9.4, we're going to be working on composition of isometries, and this is going to include what is called a glide reflection. This should be a very short lesson, but it's a very visual lesson, so I figured why not give you the time of day to actually focus on the seeing. Homework will be Math Excel, but you will have time to do it as well tomorrow, and tomorrow we're going to take care of our check of understanding. Let's get started on learning. Well, what is an isometry? An isometry is a transformation that preserves distance. Now, we've already discussed rigid motions, which also preserve distance, but today we're going to just focus on isometries. Example of isometries include translations, reflections, and rotations. Now, I really want to start to talk about the idea of composing two or more isometries, okay? What we need to take away from this lesson in general, though, is the fact that when I compose two or more isometries, in all actuality, it only produces a singular isometry. And that is the big idea for today. We're only really doing one thing, even though it looks like we're doing two. There are four types of isometries for us to talk about. I already alluded to three of them. We have translation, rotation, reflection, and now what we have is called glide reflection, which in this picture you can kind of see what glide reflection actually is. It is the actual thought that you are gliding, aka translating, and then performing a reflection, aka now you are called a glide reflection. But the big idea we'll talk about more later on. The first concept that I'd like to talk about is when I reflect twice. But when I do reflection twice, I'm reflecting specifically across parallel lines. So here I have line L and line M. These two lines are given to me as parallel lines, okay? And according to this theorem, when I reflect a triangle ABC or any other figure across line L and then reflect it once again across line M, ultimately if you look at ABC and A double prime, B double prime, C double prime, it looks just like I'm sliding, I'm gliding. AKA, I'm simply a translation. And that's the big idea of this first theorem, okay? This idea that when you reflect across two parallel lines, you are just doing a translation, okay? Because we are dealing with reflections, it's important to understand the concept that when you perform a reflection, you are perpendicular to your line of reflection. So AKA, the distance from C to C prime, it is the perpendicular distance. Okay, we're perpendicular to this line right here. All right, next example, or first example, I'm sorry. We're going to reflect J across these two lines. Now, when reading a composition, we read from the right to the left, okay? So we're first going to do a reflection across the line L. Then we're going to reflect across the line M. And notice that the question actually is ultimately focusing in on distance that I have traveled. So I'm going to go to my next slide where I actually kind of have a little bit more of a interactive way of looking at this. So we're first going across line L because we're reading from the right to the left, okay? When I reflect J across line L, my image looks like this. And then when I reflect J across line M, ta-da! J just looks like it's been translated. So ultimately what I care about is figuring out this distance that I have traveled, okay? I want to know if I measure from here to here what this length is, okay? So to help us actually figure that out, I have another thing for us to look at here on the coordinate plane. We're going to reflect this triangle ABC across these two lines that are parallel to one another, okay? So I'm going to reflect about a line. So here's my point A. I'm going to reflect it across this line, and I get A double prime here. Reflect B across this line, and I get B prime here. C across this line, and now I have C prime here. Okay. So if I connect these dots, we now have our first image. Okay. Now we're going to reflect once again these points across this ultimate other line. So here's A double prime, reflect C double prime across this line, B prime across this line, and ta-da, now I have my new points. Let me just finalize them here. And here is my final image, okay? Ultimately, I want to figure out the distance that I've traveled, okay? So if I measure my distance from A to A double prime, I have a length of 8, okay? Well, when I measure the distance between the two lines, notice my distance is 4, okay? So what I'm trying to help you notice here is, notice when I start to move my lines. Now the distance between my lines is 3, and the distance between my A and my A double prime is 6. If I move it back, remember, originally my distance is 4, and my distance was 8. If I move this line of reflection, now I have a distance of 5 between my lines of reflection, and ultimately here now, the distance from A to A double prime is a distance of 10. Can you figure out the pattern? I bet you can. Oops, didn't mean to make that completely disappear. So ultimately I care about the distance of this resulting translation. And hopefully you're picking up on the fact that the distance traveled is twice the distance between the two lines here. Okay? So if I just grab my pen, if I let this length from here to here be a length of x, okay, the total distance that I have traveled would simply be 2x, okay? So this was reflecting across two lines that are parallel to one another. The next topic we're going to discuss now is reflecting across lines that intersect with one another. So here I have this little tiny theorem, two lines that intersect from one another, and when I take triangle ABC, first reflected across line L, then reflected across line M, ultimately what has been produced is a rotation. So once again, it's this big idea that when you compose two or more isometries, it just produces really one isometry. This is another way that I could notate, right here I'm highlighting it, a composition. Notice living inside the belly, a reflection over line M is reflection over line L. That's what denotes that I'm doing it first. Okay? So we're now going to practice this question, practice this topic, and ultimately focusing on this idea of what is the center of rotation and what is the angle of rotation for our resulting rotation. Okay? So here we have J. We are first, according to the order of this problem, going to reflect it over line L. Then we will reflect it over line M. Okay? So first taking J and reflecting it over line L, we have this image right here. And then taking J and reflecting it over line M, we have this guy here. Okay? So ultimately what I'm looking to figure out is if I were to connect a point on my pre-image to my image, what is the angle? So I'm going to draw this line here to its corresponding, if I can find it, there. What is this angle measure right here? So if I pull up another observation, here is my double reflection over intersecting lines. We first have triangle ABC. We have this line right here, this angle right here is 59 degrees. So if I reflect across line 1, we have this image. Then reflect across line 2, and here's my new image. And if I show you the measure of the angle of rotation, it's 118 degrees. Let's see what happens to this angle measure if I change how much I've rotated. Okay? So if my angle measure had been 45 degrees, notice now the angle of rotation is 90 degrees. And this point right here becomes my center of rotation. So in this problem right here, this angle measure of the intersecting lines is 70 degrees. So if I were to take out a protractor, while this wouldn't be perfect, it would be approximately 140 degrees is my angle of rotation, with my center of rotation being C. My last topic today to discuss is the concept of a glide reflection. A glide reflection is simply, like I said, first doing a translation and then doing a reflection. But the key little part that you need to understand is the line that I reflect across must be parallel to the direction that I have translated. So in this paw print, I translated up. And therefore, that is parallel to a vertical line. That would be my line of reflection. So if I have here, I'm translating triangle text. First, I'm translating it -5, and that would be down 5 units, okay? And then I am performing a reflection across the line x equals 0. Well, because x equals 0 is a vertical line, that is why I know this will become a glide reflection. Well, because order matters and we work our way from the right to the left, I'm first going to translate every single coordinate down 5 units, okay? That would get me this image right here. And then reflecting across the line x equals 0, that would get me the ultimate final coordinates for e prime, x prime, and t prime right here, as we've discussed before, with reflecting across the line x equals 0. This is going to be the only got it question I actually have you do in your notes. I hope you enjoyed this very quick lesson, and I look forward to seeing you tomorrow.